All right, so in this video, I'm going to be talking about an analysis I did of the Knife Fight 2025 top 10 score results to see if averaging judge scores in battle song competitions is an effective way to determine contestant placements. Although I think it's our best way of determining contestant placements, I still want to see with this data if it's actually achieving what we want it to achieve, like removing individual judge bias. And this isn't a criticism of knife fight competition specifically. It's more of like an exploration of just this method of actually running a competition. I'd actually, contrary to that, say that knife fight is one of the most groundbreakingly well organized battle song competitions, and that's actually why this analysis is possible, because this data is actually made available. Okay, so the first thing I did was a principal component analysis of the top 10 score results matrix. And that's the results of that are what you're seeing in the top plot. So in this plot, each dot represents a judge, and the closer one dot is to another dot, the more similarly those two judges generally scored the contestants. So what you would expect to see in this scenario where the judges are judging the same clips with the same criteria to award points, you'd expect to see one tight cluster of dots. But what you're seeing actually in this plot is that there's one dot that's super far out, which represents a judge who's scoring the contestants very differently from all the other judges. And then you see just like a general spread of the other judges, which is showing that the judges are generally scoring the contestants differently from each other. You're also seeing clusters of judges who are judging more similarly within their group than they are with the other judges. And I would say this is a problem because, you know, what makes this like our competitions meaningful is that there's the assumption that there are true scores that should be awarded to give true placements to the contestants. So if some judges are scoring differently from other judges, then that means some judges are scoring incorrectly and some judges are scoring correctly. And this is even more dangerous if you have clusters of judges, because that means that there's whole groups of judges that might be judging correctly or incorrectly. And if they're judging incorrectly, that group judgment that's incorrect is going to have a larger effect on the average score of that contestant and therefore their placement. And so just to explain this box plot that you're seeing at the bottom, each row is a contestant and each dot that you're seeing is a judge's score for that contestant. So you're seeing a wide range of scores given to the contestants, and that comes to whatever average, which is the bar in each box. And so although I would say that these big outlier judges are actually a real and common thing in these battle song competitions, I removed that judge from the downstream analysis just to be honestly more charitable to the rest of this analysis. So you can still see, even with that judge removed, that there's these clusters and individual judges that are definitely distinctly judging the contestants. And you can see from the box plot that there's still like a decent range of scores given to each contestant. There's a decent spread. And a better way to look at this statistically is with this bar chart, which is just a bar chart of the average scores, and then added on as an error bar that's showing you, basically summarizing the standard deviation. And so what you're seeing is, like, for MatBat, his average score is a 42.9, but the judges disagree on his score by about 2.9 points. So he could be 2.9 higher or 2.9 lower in his score, depending on which judge you ask. And I'd say this disagreement about the contestant scoring by the judges can have a significant effect on placement, because like in a competition that's so close, with one guy getting 47.5 and another guy getting 47 points, a disagreement of 2.9 points could have a huge effect on their placement. So I wanted to do an assessment of, like, what is the actual effect on placement. So to do that, I did this bootstrapping analysis where I had the computer basically remove and replace judges to simulate different combinations of judging scenarios. And that is going to help us identify what the effect of individual judges is on the contestant placement. So basically what you're seeing is, from 10,000 different simulated scenarios of judging combinations, you're seeing in 95% of the cases what the average is with the blue dot, the average score and therefore placement of the contestant. And then the two sides of the bars are like the highest and lowest placement that contestant got in 95% of the cases. And so to interpret this plot, basically anywhere you see overlap of contestants' bars, you have uncertainty about the placement that the contestants go in. So like if you look at placements 1, 2, and 3 between Mystic, Ox, and Banks, you have no idea who really should go in first, second, and third. And this is a problem since from the PCA, we know that some judges are awarding points incorrectly and some are awarding points correctly. It's not the average of the judges' scores that's giving the kind of true placement of contestants. It's one of the simulations of judging combinations that are represented in this bootstrap analysis, and we don't know which one. And there's uncertainty about the placements, obviously, so we don't know which is the true placement scenario. So I just want to include these last two plots in here as an extra note. And I don't want people to get confused because this PCA, now you're not looking at dots as judges, you're looking at dots as contestants. And this is dots of the underlying data is z-scores, which are basically just like a way, like a transformed type of score for each contestant so that you can get a better comparison of judges' scores for each contestant. So basically what you would expect from this plot is that contestants that are closer together are contestants that judges generally, like all the judges overall, thought performed similarly. So if you guys want to kind of dive into this, I really don't have many points about it because it's like you would have to do a lot of individual points. But basically, for example, you see Jack and Matt are next to each other. If you look at a little bit more of a breakdown of this data in this heat map on the bottom, you would expect that Jack and Matt generally have the same score across the judges. And to help you interpret the heat map at the bottom, basically, if the judges thought that a contestant performed worse than average for the top 10 contestants, they would get a bluer score. And if they thought they did average for the top 10 contestants, they get a white score. And if they thought they did really good compared to the other contestants, they got a red score. So from these two plots, we can basically find the contestants who the judges thought performed similarly, and we can also identify the specific judges who critically influenced those contestants' overall scores. So from these analyses, we have pretty strong statistical evidence to conclude that there is significant variance in the way that the judges are scoring the contestants, and this variance has a significant effect on the contestants' placement. We don't know which components of that variance are due to undesirable effects, which are going to cause the contestants to be placed incorrectly. And I think this is the most frustrating thing about battle song competitions because it just shows that we don't have a good framework to judge how well everybody did in the competitions after we put in all this effort to have like a competitive experience.